Hello everybody, and welcome to example 4 on page 38 of the workbook. Let's take a minute to read this example together. So they'd like us to write each of the following permutations in S7 as a product of 2 cycles. And they give us a list of 4 permutations that we want to do that with, and then to categorize these permutations according to whether the number of 2 cycles is odd or even. Okay, so let's start with the first part of the question, the product of 2 cycles. I'm going to show you kind of a nice systematic way that you can do that with any permutation. We'll start with the 3 cycle, 1 goes to 2, goes to 3, goes back to 1 again. Okay, here's how we can decompose this into a product of 2 cycles. We're going to start by noticing the first and the last element, 1 and 3, and just make a 2 cycle, okay, with those 2 numbers. So 1 goes to 3 and 3 goes back to 1 again. Then next, what we'll do is notice the first element and the second to the last element, 1 and 2, and write down a 2 cycle with those 2 numbers in it. Turns out that that product of 2 cycles is going to be equivalent to the 3 cycle that we started with. Okay, let's try that same method out on the next permutation, alpha 2. Okay, there we're starting with a 4 cycle, and we can use the same idea. First thing we'll do is notice the first and the last element, make a 2 cycle with those 2 elements in it. Then we'll move down to the first and the second to the last element, 1 and 3. Okay, and then finally, the first element and the third to the last gives us the first and the second element, so we're just going to get 1 and 2. Okay, does this really work? Let's take a minute just to check it for alpha 2. Okay, it would be disappointing if what we're writing doesn't make any sense here. Okay, so what we can do to check alpha 2 is to start with the decomposition that we got on the right-hand side, 1, 4, 1, 3, 1, 2, and actually do that calculation and confirm that it gets us back to this alpha 2. All right, so we'll start with the number 1, and let's see. 1 goes to 2 in the first, or in the rightmost cycle, and then notice that there are no 2's in those two, in the first 2 cycles, and so 1 goes to 2, and that's where we end up. Okay, then next, where does 2 go? All right, well, let's see. So 2 wraps around back to 1, and 1 goes to 3, and there is no 3 here, so 2 goes to 3. Okay, and then finally, check and see where 3 goes. So there's no 3 here. 3 wraps back to 1, and then 1 goes to 4. And so 3 goes to 4. And you can double check that 4 is going to wrap around and go back to 1. Okay, and so that confirms that this product of 2 cycles that we came up with really does give us that 4 cycle, 1, 2, 3, 4. All right. So let's see if we can do that for the last 2 permutations here. So alpha 3 looked like 4, 3, 6, 7, 2. If we use the same method, always going to start with the first and the last element. So we'll have a 2 cycle that looks like 4, 2, and then 4, 7 would be the next one, 4, 6, and finally 4, 3. Always the same pattern. Okay, and then what about alpha 4? Okay, well, let's see. Here we're starting with 1, 6, 3, 2, composed with 4, 5, 7. So we've actually got a product of cycles in this case. Okay, and so to do this decomposition, we can just do it one at a time, basically. Okay, so we'll start with the 1, 6, 3, 2 and write that down as a product of 2 cycles. So that's going to look like 1 and 2. Those are the first and the last elements. Okay, and then followed by 2 cycle with 1 and 3 in it, and a 2 cycle with 1 and 6 in it. Okay, that takes care of the first cycle, and we're ready to move on to the second one, 4, 5, 7. If we write that as a product of 2 cycles, we'll start with the 4 and the 7, the first and the last element, followed by 4 and 5. Okay, and if you wanted to, you could check and just confirm that those calculations that we did are accurate. Okay, So we've completed the first part of this question. We've written all of those permutations as a product of 2 cycles. Let's move on to the second part of this question. Okay, so it would like us to categorize the permutations according to whether the number of 2 cycles is even or odd. All right, so let's circle our answers here, one by one. Notice that for alpha 1, we were able to decompose that as the product of 2 cycles. So since it's 2 cycles, we would say that the number of cycles is even in the product. Okay, moving on to the next one, alpha 2. That was a product of 3 2 cycles. 3 is an odd number, so we would say that this is an odd number of 2 cycles. Okay, and so on. All we're really doing here is counting the number of 2 cycles in our decomposition. Okay, we could do this for any permutation in S7. Okay, which brings us then to Theorem 5.4, which is kind of a general statement about products of 2 cycles. And it just says this: every permutation in Sn, for n greater than or equal to 1, can be written like this, as a product of 2 cycles. Okay, we can use this method to represent our permutation that way. And then, okay, because we're either going to have an even or an odd number of 2 cycles, that decomposes the set of all permutations into exactly 2 categories, depending on whether that number is even or odd. Okay, so let's read this statement together. We say that a permutation is even or odd if it can be written as a product of even or odd number of 2 cycles. And if you take a look at Theorem 5.5 in the book, it guarantees that every permutation is going to fit into one of these 2 categories.